Good morning everybody. So in this session we will understand more about one important aspect in software engineering, which is nothing but the system design. So design is not that much easiest concept, so it is very difficult. In the previous classes we have understood about analysis and introduction to what? Software engineering, object oriented software engineering. So in this module we will call this as the module 3. So in this module we will concentrate more on design aspects, how exactly we can design a system. So that particular the module we are able to call this as system design. Okay, basically you understand what exactly the system is a design is. So basically it is the transformation of an analysis model into a design model. That itself is system design. Okay, so how exactly you may define a system design as it's a transformation of an what? Analysis model. So it is very important. Previously we have concentrated more on analysis, requirement analysis, what exactly the user required to build a system. So it may be in terms of software, it may be in terms of hardware, right? So basically we need to have a analysis, right? So analysis model, that is into what? A design model, right? So basically we need to do, if we take one particular example, right? So analysis means, so if we take a constructing one kind of house, right? So basically we will see first the site where exactly we can construct a house. So that it, whether it may be a house may be constructed or not, that we need to analyze, right? So if that is not accurate, right, that is to build to construct a house, then we are not supposed to have a good analysis, right? If we take any particular area and then we are able to construct one kind of house, it is not possible. That's why we need to analyze it, analysis, whether it can be done or not. So that is how we are able to analyze this. We need to transfer whatever we have done with respect to analysis, that is into a design model. That itself we may call it as the system design. Okay, and then here system design is not algorithmic. It is not algorithmic. Okay, so basically key points I list out. So it is not, it may not be algorithmic. Algorithmic means by keeping a particular algorithm that is into the consideration, right, we are going for building a model. That is not the case. So here it's not algorithmic, right? So here I will go on writing one kind of word as not algorithmic. Okay, it is not algorithmic. And here what exactly we are able to go on what? Designing a system. So in that context, right, so usually here we are able to go on following some of the, we may say it as the rules. So what exactly we need to understand as and when we need to design a system, that we need to understand now. So here we have to go on what? Keeping a track of certain things. What exactly we'll see now. First is identify design goals. First what you have to do, you have to go on identifying the design goals. Okay, so that is the first one. And second one, we have to go on design the initial subsystem. Very important word here, decomposition. You have understood this in your software architecture, right? So as and when we are understanding about the different modules, as and when modules will come, so we may have a word which is called decomposition. Third one will be refinement. Okay. So here we have to go on following the 3 different steps, you may say. One is to identify design goals. What exactly the user need to achieve. So that is what design that you have to make by using any architectural styles. It may be pipes and filters, it may be a repository, it may be one kind of a blackboard, it may be one kind of you may say a layered system. So plenty of it may be a model view controller. So plenty of architectural styles are there, right? So that is to build a design or a model. So at that point of time here, what we are able to see, the user is to identify the design goals, right? So that is the first main important characteristic. So there we have to go on describing the qualities and goals of the system. Qualities and goals that we have to list out. So we need to go on discussing about qualities and goals of the system. So it is very important. And then second one, we have designed the initial subsystem. Initial subsystem decomposition. Decomposition means dividing that into different models. Dividing that into different models. And here we are going with the different, it may be a use case model, it may be one kind of analysis model, it may be anything. So here what we are doing, we are decomposing it. Design the initial subsystem decomposition. So that is the second step in your the system design. Third one will be refinement. Refinement means improvement. Certain improvement that may be done, that may be possible for a subsystem decomposition that you may do. So that is why we are able to call it as the refinement. So that is the third possible step that you may find. So any refinement, right? So if the desired amount of decomposition of a subsystem is not satisfied, then we may go on refining it. So that is the third possible point that you may come across with respect to one particular context. Here we are able to say it as the in designing one kind of a system. Okay. So now as we move on here, we are going with the particular activity. That is, we will take one particular example. So here we have a example that has been given in your textbook, that is called a floor example. It has been given as the floor example. Okay, floor. So usually here a floor example. Okay, so floor example. What exactly? See, as and when we may go on finding or not specific to that, we may take any particular house example. Okay, sketch house example. Okay, so here what exactly you may find? See, here a house we have to plan, right? So in that, if you take this as the plot area, okay, so here it is nothing but in this plot only. Let us say this is a dimension of 30-40. So this is a 30-40 site. So in this one, what exactly we are looking for? We need to construct a house. So we need to plan, let us say, and based on, so we are all giving much of the importance for Vastu, right? So in that context, if you give this particular a sketch, that is to one kind of an engineer, he will design. How exactly he will design? If you enter, so this will be left for, let us say, this portion will be left for the car parking, right? If it is north side, then we are able to go on placing one kind of borewell here, and the water tank will be here. Okay, so that is the north face. And then here you may find one kind of one kind of a bedroom. You may say this as the master bedroom. Okay, and then you may find here it as the, let us say it is kitchen. Okay, it is called kitchen, and here you may have one kind of an area. Okay, and then here you may have one more kind of one kind of one washroom. You may take it as the washroom, and this will be the hall. This will be the hall, and one more bedroom also you may place. So this is how we are able to design. So why exactly I am insisting is, this is a one sketch, version 1. You may call this as the version 1. And another engineer, so he may go on what placing, he may change. Let us say here in this area he may go on placing kitchen. Previously what we have placed, master bedroom, right? And here he may place one kind of washroom, or else he may place one kind of bedroom. And here at last he may go on what, placing one kind of washroom. Getting right? So the version of this particular sketch based on, or if you go on what, giving one kind of what a design, right, that will change from one particular a person to another particular person. So that is how we are able to go on what, understanding that is based on this particular context, is based on one kind of activities that are to be placed within a given particular framework, within a given particular frame. So that is why we are able to, if you have studied one kind of the concept of data mining, right, then we are able to call it as framework. What exactly the meaning of framework means? Fitting all the given particular activities that is into a single frame, that is called as framework. So this is one simple example, right? So we have taken house example. If you take one kind of the one kind of the floor example, right, that is also, that may be also be there. So if you are able to go on what, placing one kind of granite, it may be marble, it may be one kind of vitrified. So there may be plenty of varieties that you may find. So that is how exactly, how attractive I can make my house, and how exactly without wasting a single portion, right, how exactly I can construct my house. So if you are going on designing such kind of aspects, right, then this particular strategies are very, very important. So this is one simple example why exactly we need to give much of the importance for design. Okay, so it is called planning. So if we go on what, one kind of mapping one kind of architectural software engineering concept, right? So basically here we may have one kind of components. We may find we have one kind of components, right? We have interfaces, absolutely we needed, that is especially which is needed for the communication aspects. Now non-functional requirements, it is also required. Non-functional requirements, absolutely needed. And then fourth one, we have functional requirements, it is also mandatory, functional. And the fifth one will be, it is rework. Okay, so these are some of the parameters that I may list for some of the architectural concepts. Now here I may go on what, taking components that are being required for constructing one kind of rooms. Absolutely it is needed for rooms. And then the interfaces that are being necessary for giving one kind of doors. Doors are nothing but what, interfaces, right? So it communicates, communication, right? So that is why we are able to say interfaces are nothing but doors. Non-functional requirements will be your living area. It will be a living area. It will be one kind of a non-functional requirement. Functional requirement will be residential house. Residential house, you may say it as the functional because it is mandatory. So this is what we are able to look into. Rework is moving walls. Moving walls. What exactly these are? These are architectural concepts. While designing a system, right, we need to give much of the importance for architectural concepts. So in that one, components are required. Components are nothing but, so it's an architectural style will come, that is called components and connectors. So we may call them in other words as pipes and filters. Filters are nothing but components and pipes are nothing but connectors. If you want to connect, right, so these are nothing but two components. Let us say these are the two components. To connect these two components you need a pipe. So this is called pipe and this is called filter. In other words, we may call it as, this as the component, right, this as the component, and this I may call it as a connector. This I may call it as a connector. Getting right? So this is how we are able to go on what understanding the architectural components. How exactly we may map one kind of the architectural components with the given possible the requirements. So here components, you may call them as rooms. Interfaces are nothing but doors. Non-functional requirements will be the living area, and functional requirements will be residential house, and rework will be one kind of, what you may say, it's moving walls, because you may say it as a costly rework, because if the moving walls are nothing but what, very costly. So that is why we are able to say it as the one kind of the moving walls. So these are some of the architectural aspects that we are able to understand, and it is one kind of the mandatory with respect to the metrics, you may call. By having such kind of metrics, you may go on deriving the architectural concepts. Okay. So next, the topic, second topic, right? Next topic that we want to understand in our system design will be overview of system design. Overview of system design. Okay. So in this one, right, we have to understand some aspects. First one will be non-functional requirements. Non-functional requirements and constraints, you may say. Second one, use case model. Third one, it will be analysis model, or you can call it as object model. And fourth one will be a sequence diagram. So these are some of the products of system design. One is the non-functional requirement, right? Non-functional requirement, it may be a response time, it may be a response time, it may be a throughput, it may be a throughput, it may be one kind of reliability, it may be a reliability. So like this, you may go on what listing the important requirements, non-functional requirement. Either it may be a response time, either it may be a throughput, either it may be a reliability. So that those we are able to list it as non-functional requirements. Next, if we come to the second one, right, so that is use case model. So use case model, what it describes the functionality of the system. It describes the functionality of the system. It describes what? It describes functionality of the system. It describes actually functionality. How the functionality of your system. How exactly the different components are working. Functions. CPU is necessary for doing one kind of processing. Input unit is necessary, that is for accepting the input. Output unit is necessary for giving one kind of the output, right? So in the similar way, here we are able to make use of use case model. And while writing the use case model, we are able to make use of actors. And what are the functionalities that are being done by the actors, right? So That's about the second one, use case model. Next, if we move on here, we have object model. What exactly? So it describes the entities. It describes entities manipulated by the system. Entities manipulated by the system. Manipulated by the system. Okay. So entity means all real world objects are entities. You may say all real world objects are entities. That is why we are able to say it as object model. What exactly it describes? Entities that are being manipulated by the system. That is why we are able to say it as object model. Next, fourth one will be, we are able to say it as a sequence diagram. What exactly? So it is necessary for giving sequence of interactions. It is responsible for giving sequence of interactions. Sequence of interactions among objects. Among objects. So that is why it is necessary. So if we go on understanding the overview of the system design, we have non-functional requirements. Non-functional requirements may be a response time, it may be throughput, it may be a reliability. Okay. So we are able to go on taking the use case model. It actually describes the functionality of each and every particular function which are being done by the actors. Next is object model. It describes the entities manipulated by the system. And sequence diagram is necessary for representing the sequence of interactions among what? Objects. So this is about one overview of the the system. Overview of the system design, we may say. And if we come to the next one, right? So if we come to in that topic only, if we take the next one, what exactly we need to understand now here is, we have to understand the results which are being of the products, right? So if we go on listing the results which are being obtained by the products, one is the design goals. We have discussed that, right? So second one, software architecture, mandatory. Software architecture is not engineering, it is architecture. Third one is boundary, use cases. Boundary, use cases. So these are the three important products that we need to understand. One is the design goal, second one is the software architecture, and third is the use cases. What exactly the design goals? So it describes the qualities of the system. It describes the qualities. It describes the different qualities, okay, qualities and goals, you may say, qualities of the system, and that so that the developer should optimize. The developer should optimize. So that is how we need to go on setting our goals. It should not be too high. Let us say, I am supposed to score 100%. No, it should be, you should aim such that it should work 150%. No. We should go on having a quality, and it should have the scope for optimization. So that is why we are able to go on having design goals. Next is the software architecture. What exactly it describes? It will describing the system decomposition in terms of subsystem responsibilities. Subsystem responsibilities, right? So it describes the subsystem responsibilities. So it describes subsystem responsibilities, dependencies, how it is dependent with respect to the other one, dependencies, and usually here we are able to go on having one kind of the mapping. Mapping means a relationship among other objects. We may call it as mapping, right? So basically it is the software architecture, we may say. It's nothing but a program, you may say. So that actually results in, one kind of the activity towards the subsystem responsibilities, fine, dependencies, and followed by mapping. That means mapping means here we are able to say it as the, we may say it as the one kind of the interactions, right, or how exactly the behavior of the system. So to study one kind of the behavior of the system, right, we need to go on what, mapping it. So that is why we need the second the product, right, second result, we may call it as the software architecture. Third one, we may have a boundary use cases. What exactly? They will describe the system configuration. So system configuration in terms of, it may be a startup, it may be shutdown, it may be exception handling issues. So basically it describes system configuration. System configuration in terms of, it may be one kind of startup, it may be shutdown, it may be exception handling issues. It may be exception handling issues, right? So this is how we are able to go on understanding the results of the products. One is the design goals. It actually describes the qualities which are being necessary and qualities of the system, that so that the developers should optimize. Software architecture, it mainly concentrates on the subsystem responsibilities and their dependencies and interaction between the different external behaviors, external visible properties, you may call it as. So that we may say it as the mapping. Third is the boundary use cases. Boundary use cases that actually describes the system configuration. It may be a startup, it may be a shutdown, it may be any exception handling issues. Okay. So this is about results of the products. Now, if we move on, so we will go with respect to the activities of the system design. So in that activity side, we have analysis, activities of the system design. We have design and we have object design. We have system design and we have object design. Okay, one diagram that will come, object design. Okay, and then here in the analysis part, right, it is related with respect to the dynamic model. It is related with respect to the dynamicity. Dynamic means rapidly changing. That is called dynamic. And then here we have one particular context towards non-functional requirements. It may be a non-functional requirements, that is majorly it depends on the design part. Okay, it actually depends on the design part. And analysis is also related with the analysis object model. This we have understood in our analysis part, right? So we have two things. One is the dynamic model and second one is the object model. So now here we are going with the system design, right? So in the system design, we are going with the system design concept, right? Design goals. We are going with design goals and subsystem concept. Here we are going with the subsystem concept. Subsystem decomposition, we may say. We may say it as the subsystem decomposition. Okay. And next, here in the analysis object model, right, that may result in here object design. That may result in object design. Okay. And object design, that may result in object design model. It may go on what saying here, object design model. Object design. So this we may say it as the activities of system design. We may say it as the activities of system design. Activities of system design. Activities of system design. So we have analysis, system design, and we have system design, object design, and with respect to that we have non-functional, and we have non-functional is related with the system design. because we have one kind of reliability, we have throughput, we have response time, right? So we may say it as non-functional requirements. We may say it as the non-functional requirement. And dynamic model is associated with here. The dynamic model here is being associated with the system design. Absolutely, it is associated with the system design. And analysis model, object model is associated with the object design. And system design is associated with design goal and subsystem decomposition. And here the object design has been related with respect to the object design model. So these are we may say it as the activities of system design. So this is very important from your understanding perspective. Okay. So after this we have to go on understanding next one, subsystem design concepts. We will understand subsystem design concept. Subsystem design concepts. So in that one, right, you will understand two things. One is the subsystems, subsystem. So basically we know what exactly a system is. Sub means small part, and second one we need to understand about classes. Okay, classes means collection of objects. So these are some of the things that we need to understand in subsystem design concepts. First, initially we will understand three important terms in subsystem design concepts. One is the coupling. What exactly the coupling is? Coupling measures the dependencies between two subsystems. Important terms, right? So it actually measures the dependencies between the two subsystems. Second one, we have to understand layering. We have to understand about layering. What exactly a layer is? It's organized as a hierarchy of subsystem. Hierarchy of subsystems. Hierarchy of subsystems. Next, we need to understand about partitioning, division. Organizes subsystem. Organizes subsystems, right? And it provides different services. It provides different services. Fourth one, it's cohesion. You may say it as the cohesion. It actually measures dependencies among classes. Here it is between subsystems, but here it is, the dependencies among classes. That is the only difference that you can make out with respect to the cohesion and coupling. Cohesion and coupling. So these are the main important the definitions, right, that they may ask in the examination. Define coupling. So it measures the dependencies between two different subsystems. Layering, it is the hierarchy of subsystems. Partitioning, so it organizes subsystems and it provides different services to each other. Cohesion, that the dependencies among classes. So these are the main important the concepts that we need to, definitions that we need to understand before going for subsystem concepts, right? So after understanding these definitions, we need to understand the main important one, that is called subsystems and classes. We may say it here as subsystems and classes. Subsystem and classes. Basically, a subsystem is a replaceable part. A replaceable part of the system. Replaceable part of the system, right? So with well-defined interfaces and encapsulations, right? So usually here it's nothing but a subsystem, a replaceable part. It may be replaced by some other particular part. Okay, and then second one we need to understand about classes. Classes means it's collection of objects. Collection of objects. We may say it as classes as the collection of objects. Collection of objects. Okay. So these are nothing but the two important aspects that we need to understand in what? System design concepts. Basically here we will understand one important activity with respect to the one particular thing here. So we will understand that with the help of an example, right? So that we may represent here, we may write here a UML diagram. So that we will understand by a UML. Okay. So we have a system. We have a system. Fine. We have a system, and then we have class here. We have a class here. Okay. And we have a subsystem here. We have a subsystem, right? And then these two are being associated with a part. These two are being associated with the part, right? So these two I will write like this, and then here I will write an aggregation symbol, and then this is a part of this, and here I will go on what? Representing this with this. Okay, it is connected to a system, and through that particular subsystem, right, we are going with the system here. It is connected with the help of a rhombus here, a rhombus. Okay, so what exactly we may understand that segregated is it is associated. It is associated and it is aggregated. Okay, and here we are able to place one kind of a star, not with respect to. It means any to many to many. You may say many to many. So it's one means 1 comma 1 if you write 1 to 1. So those are the relationship that you may exhibit with the different entities. So here we are going for understanding the subsystem decomposition, that is UML class diagram. Subsystem decomposition. So that is, it will be represented as the UML diagram. Okay. So basically here we have a system, and then we have a part. Part being is been associated with class and subsystem, and that is in turn that aggregate to what? A system. And in turn a part, right, any replaceable part, right, so that is associated with the subsystem. So that is how we are able to understand one particular UML diagram. And as we derive one kind of the definitions. If we are able to go on what deriving the definitions means, it is very much important with respect to the different things that we are able to give. Okay, so this is about subsystem design concepts. In that subsystem design concept, right, the first one will be subsystem decomposition. Subsystem decomposition. So and in my next class we will understand more about the different particular things: cohesion, layering, decomposition, and then we are able to understand about services and subsystem interfaces. So this is the UML diagram of kind of subsystem decomposition. So in my next this one video, where we will understand more about how exactly the layering, cohesion, structuring, organization, and still more important activities with respect to the design.